Hello guys, welcome back to our channel. Today we are going to discuss about D flip-flop and how to make the Verilog code for this D flip-flop. Before going to the D flip-flop, one device is the SR flip-flop which we are already discussed in our previous videos. You can also refer to this video. I will provide this video at this high button. Okay. Okay, this is a SR flip-flop and this is the truth table of the SR flip-flop. If you observe that here always S and R inputs are complement to each other. That means if S is 0, R is 1 and S is 1, R is 0. And here you can observe that these are complement to each other. Yeah, right? And you can ignore the other cases because 1 it is the not used. That means the state is not useful for our condition, and 0 is nothing but the memory. So the major and the main conditions of the SR flip flop is this, and here the S and R inputs are different. So we can modify these connections by here I am again drawing this diagram SR flip flop. The outputs are cross connected each other. Yeah, we already know that. Here I am giving the clock pulse and I will modify here the circuit is here I am giving the D as the input and I will just connecting an inverter to the circuit, so that if we apply 0 here, then it will be applied here at the 1, and if we apply at 1 here, it will be applied as 0. In this way we can convert the SR flip-flop to the D flip-flop just by connecting an inverter between the two NAND gates at the input. Okay, here we can also indicate this as this one as the D, and we are applying the clock here. The symbol is representing it is an edge triggered because of flip-flop is a edge triggered device, right? Here Q and the Q bar, and here I will take as an input and I will connecting an inverter and I am giving this. In this way the D flip-flop will be designed. Let's see the truth table of the D flip-flop. Here I will writing the D, clock and the Q, right? Here if it is a 0, irrespective of the other input, Q will be act as a memory or it will store some value, and if it is 1 and D is 0, that means D is 0. In this case now S will be 0 and R will be 1, right, according to our logic. So S equal to 0, R equal to 1, the output Q is 0. So here 0, and if D is 1, that means S is equal to 1 and the complement to R is equal to 0. Now S equal to 1, R equal to 0, the output Q is 1, right? Yes, 1. And next condition will not be possible, not usual, because only these combinations can be possible in the D flip-flop. In this way we can design the D flip-flop. Now we will see how to make the Verilog code for this D flip-flop. Guys, now let's start making the Verilog code for the D flip-flop. So I am creating the module, a name called DFF. I'm entering, and we will require some inputs like I am taking the reset, clock, and a D, and we require some outputs, output register Y, and here I am mentioning the register, right? This register will be used to store the values, so that based on those values the output will be changes. So I am using the always, which is nothing but the behavior modeling. Always rate posits clock. Okay, posits clock begin if reset means if reset equal to 1, then what will happen? Y is equal to 0. Okay, and I'm ending this, and else if reset is not equal to 0, then y is nothing but y will be equal to the D, and ending this, and I will end the, and sorry, here we have to mention another begin, right? Begin. Ending the always block, and I will finally end the module. So this is the code required to design the D flip-flop module. Now let's start making the code for test bench. So far I am creating the module TV. Here inputs are nothing but register, reset, clock, and D, right? And for the outputs, Y. I'm extracting the inputs and outputs from the main module, DFF1. Here what will be the reset, clock, D, and Y, right? Now I am start giving the test bench. Before that, I will give the clock equal to 1, and forever means until and unless the test bench completed, the clock will be changed continuously. I will give some delay. For every 10 seconds, clock will be changed to its complement state. Okay, now I am ending this. Now I will give the an actual, but before that I will give that some dump file commands so that we can see the output after our execution of the code. Dump file.vcd and $dumpwares equal to 1. Okay, now I will start giving. First I will initially start reset equal to 1, and D I will give some 0. We'll check whether it is working or not. Then and next I will give reset equal to 1, D equal to 1, and a hash 10. I will equal to reset equal to 0, D equal to 0, and again some giving time delay hash at 10. I'm just copying this sequence so that we will easily give the sequences. Here I will now again I'm giving the 0, right? And now I will again reset equal to 0, D equal to 1, hash 10. Again I will reset equal to 0, D equal to 1, hash 10. Now I am finishing this statement by giving the $finish command. I'm ending this and end module. So this is the test bench required for our D flip flop. Now I will select some tool to execute this file, and I will select the open API. I'm going to save this file, and I will add some name called D flip flop to save this file. So I'm giving the name called D flip flop. Sorry, D flip flop, and again saving this file, and I'm gonna to run this again. As we got the output, here you can observe that initial the reset is equal to 1. So irrespective of the inputs, the output is 0. Okay. Next, here the clock pulse is I and the D input is 0. Reset is also 0. So Y is again 0. And here you can observe that this is a level triggered device. The flip-flop is actually a level triggered device, and it will changes only when the edge is changing, then only the state will be changes. Here when the again the positive edge of the clock obtained, here the D is 1, so output 5 will be changed into the 1. So in this way the edge triggered flip-flops will be work. And thank you for watching this video. If you have any doubts, please mention in the comment section. You can get this code in the description. I will provide the GitHub link, and stay tuned for the next video.